Welcome to Programming Fluency. This is section 4.2, Parameters and Prototypes. You already know how to write functions that receive values and return results. In this video, we answer one sharp question. When you pass a variable to a function, does the function get the variable itself, or a copy? Let's begin. You already know how to write functions that receive values and return results. Now we answer one sharp question. When you pass a variable to a function, does the function get the variable itself, or does it get a copy? The answer shapes how every C program behaves. Let's find out. This is the plan for this video. First, we sort out two words that are easy to mix up: parameters and arguments. A parameter is what a function declares. An argument is what you actually pass in. Next comes the big idea: pass by value. When you call a function, it gets a copy of your value. So changing a parameter inside the function does not change the original back in the caller. Then we look at the right way to get a value back out, using return. You will also see how the types convert when they do not match exactly. Finally, you meet function prototypes. A prototype lets you declare a function before you define it, which helps you organize your code across a file. You've written functions like square that take an integer and return a result. The caller provides a value and the function receives it, but one critical question went unanswered. When you pass a variable to a function, does the function get the variable itself? Or does it get a copy? This matters because the answer decides whether a function can change its caller's data. If main has a variable x equal to 10 and calls modify of x, does x change? In some languages, maybe. In C, the answer is no, and understanding why is essential. Before the mechanics, let's clarify two terms that are easy to confuse. In int square of int n, the parameter is n in square of x. The argument is x, which has the value 5. The parameter is a placeholder inside the definition. It exists only inside the function. The argument is the actual value the caller sends. When the function is called, the argument's value is copied into the parameter. This is the single most important concept in this section. Let's define it. Pass by value means, when you call a function, the argument's value is copied into the parameter. The parameter is a brand new, independent variable. Modifying it inside the function has no effect on the original argument in the caller. Get this right, and the rest of C's function behavior makes sense. Let's watch pass by value in action. The function try to double takes a parameter n and doubles it. Inside the function, n goes from 10 to 20. But look at the last line of output. X is still 10. The function doubled n from 10 to 20, but x in main never changed. The function worked on a copy, not the original. Let us watch pass by value in memory. This is the caller's variable. Exit lives in main's memory, and it holds the value 10. Now we call the function. C makes a copy. The value 10 is copied from the argument x into the parameter, and the parameter n is a brand new, separate box that holds its own 10. Inside the function, we run n equals n times 2. That changes only the parameter, and its copy goes from 10 to 20. And here is the key point. The caller's variable is unchanged. Look back at x, it is still 10, untouched. The function changed only its own copy, never the original. Let's trace it step by step, tracking both boxes. Follow the two middle columns. N changes and x never does. Before the call, x is 10, and n does not exist yet. When the call starts, the value 10 is copied from x into n. When n equals n times 2 runs, n becomes 20, but x stays at 10. On return, n is destroyed, and x is still 10. Why does C work this way? Pass by value is a safety mechanism. When you call a function, your local variables cannot be changed behind your back. The function gets a copy, does its work, and returns a result. You do not need to read the function's body to know it will not touch your variables. It does not. Looking ahead, in Chapter 6 you will meet pointers. Passing an address lets a function reach back and modify the original, but the pointer itself is still passed by value. That is not an exception to the rule. When a function takes several arguments, each one is copied separately. Here swap exchanges A and B inside the function. A and B really do swap. The output shows A equals 7, B equals 3, but X and Y in main are unchanged. 3 and 7 in the original order. The function swapped copies, not originals. A function cannot modify its caller's variables through pass by value. So if functions cannot change their caller's variables, how do you get results back? You already know the answer. Return. Instead of trying to modify a parameter in place, compute the result and return it. Here, x changes, but not because the function modified it. It changes because main explicitly assigned the return value back into x. The function computed 10 times 2 equals 20, and returned 20. Then main stored 20 into x. This is the standard pattern in C. Parameters have types, just like variables. When an argument's type does not match the parameter's type, C applies the same implicit conversion rules you learned earlier. Passing an int to a double parameter widens it. 7 becomes 7.0. That is safe, no information lost. Passing a double to an int parameter truncates it. 3.14 becomes 3. That loses data. Passing a char to an int parameter widens it, using the character's code value. That is safe. Passing an int to a char parameter narrows it, keeping only the low 8 bits. That is risky. Best practice. Match your argument types to your parameter types. For a narrowing conversion, use an explicit cast to make your intent clear. Until now, every function had to be defined above its first call. For 20 functions, that gets awkward. You want to read main first. Function prototypes solve this. A function prototype is a declaration of a function's name, return type, and parameter types, ending with a semicolon without a body. It is also called a forward declaration. It tells the compiler enough to check calls before it sees the full definition. The syntax is the return type, the function name, the parameter types in parentheses, and a semicolon. This is the prototype in action. The third line is the prototype. It tells the compiler there is a function called square that takes an int and returns an int. When the compiler reaches square of 5 in main, it verifies the call is correct. One int argument, matching the prototype. The full definition appears after main, and the linker connects the call to it. A few notes. A prototype ends with a semicolon and has no body. Parameter names are optional. Int square of int is also valid, but naming them documents what the function does. And always use void inside the parentheses for a no-argument function. With prototypes, you can write main first and define helper functions below. This is the conventional C organization. Main appears near the top, where a reader looks first. The prototypes above it act as a table of contents. At a glance, you see the program has helper functions. what types they take, and what they return. The full definitions are below, available when you need the details. You will see this convention in virtually every C program of significant size. This is a sharp edge. The prototype and definition must match exactly. Same return type, same parameter types. If they do not match and they are in the same file, a modern compiler rejects it with a conflicting types error. But the real danger appears when the prototype lives in one file, often a header, and the definition in another. Nothing forces them to agree. The program compiles and links, and the behavior is undefined. Main expects a double, but the function returns an int and you get garbage. The prevention is simple. Copy the first line of your definition and add a semicolon. No typos. You may have noticed something that seems to contradict pass by value. When you read input, scanf does modify age in the caller. How? The secret is the ampersand. Ampersand age does not pass the value of age. It passes the memory address of age. Scanf uses that address to write directly into age's memory location. And here is the subtle part. The address itself is still copied by value, but an address lets scanf reach back and modify the original variable. This is a preview of pointers, which you will learn in Chapter 6. Let's recap. C passes arguments by value. The argument's value is copied into the parameter, creating an independent variable. Modifying a parameter does not change the caller's variable. Return computed results instead of trying to modify parameters in place. Scanf needs the ampersand because it passes an address, not a value. A prototype declares a function before its definition. It ends with a semicolon and has no body. The convention is prototypes at the top, main next, and definitions below. And a prototype must match its definition exactly, or the behavior is undefined. Next, you know how values move into and out of functions, but where do variables live and for how long? In the next section, you will learn about scope, lifetime, and storage.